Okay, so far in the unit, we've talked about the sine law, we've talked about the cosine law. Basically, we should be able to solve any oblique triangle. Now, we are going to progress to do the word problems involving oblique triangles, but before we do that, we want to learn about bearings. So bearings is basically a way of indicating direction, and as you'll see later on, it's very important that you can read the direction from the bearing, because otherwise you won't be able to interpret the problem and draw the correct diagram. So there's two ways to indicate direction, at least two ways that we are going to cover. So the first way is using true bearing. So a true bearing is an angle measured in degrees in a clockwise direction due north. So bearings are used by sailors and pilots for directions. So the key idea is you start north and you rotate clockwise. So for example, I've said the bearing of 90 degrees is east, right? Because you start at north and you go 90 degrees and you'll be pointing in the eastward direction. Now what about a bearing of 180 degrees? 180 degrees, which means you're going to be pointing south. What about 270? 270 would be west, right? So 90, 180, 270. So it's west. 45 degrees, we're looking at northeast. And now a bearing of 135 degrees. So we're looking at about here, right in between east and south. So that's southeast. Okay, and of course you can say a bearing of 5 degrees or 6 degrees, but if it's these perfect beautiful numbers, then you can convert it to south or west or northeast, southeast, so forth and so on. Okay, so you know what, let's practice our knowledge of bearings and try to solve a problem. Okay, so Alex and Haley are both walking home from school. Alex walks 550 meters on a bearing of 280 degrees. Haley walks 780 meters on a bearing of 38 degrees. Okay, so let's say this is the school. Okay, I'm going to draw these this little cross here to help us with the bearings. So let's see, Alex walks on a bearing of 280 degrees. Now remember, 270 was west, so 280 is a little north of west. Okay. And then what about Haley? Haley walks 780 meters on a bearing of 38 degrees. So that's very close to being northeast. Okay, so this was Haley, and this was Alex. So Haley walks 780 meters, and Alex walks 550 meters. Okay, so this is cool, by the way. Now, I want to know how far apart are the houses. How far apart is Haley and Alex's houses? So, you know, if this is what I'm trying to solve for, say this is X, you know what? Having this angle here is really going to help, because then I'll have two sides in a contained angle. You know what? Let's put, so this here is 38 degrees. Okay, because that was on a, Haley was walking on a bearing of 38 degrees. Now, what about this angle here? Well, this is 10 degrees. Now, how do I know? Because it's 280 degrees, right? 280 degrees is 270 plus 10. So let's here a little 10. So these two angles here are supplementary. So, sorry, they're complementary. They add up to 90 degrees. So this is 80 degrees because it's one quadrant, right? So, you know, I'm going to blow that up. I'm just going to make sure we're perfectly clear on what is there. So this is 38 degrees here on a bearing of 38 degrees. And obviously not drawn the scale. This is 10 degrees. So which means this is 80 degrees. Okay? So angle S is equal to 80 degrees plus 38 degrees, which is 118 degrees. Beautiful. You know what? I think we can solve for x now. Using cosine law like we stated before. It's going to be 550 squared plus 780 squared minus 2 times 580 times 780 times cosine of angle S, which was 118. Okay, and punch in your calculator. Oops, I had a typo in there. It's 550. So 1146 about. So just over a kilometer. Okay. So the hardest part of this question is really just solving for the interior angle there. You really have to have a strong understanding of bearings. Okay, so let's do one more. Okay, for example 2, we have for Jamie to reach Sean's house, she must travel 4.6 kilometers on a bearing of 192 degrees. Unfortunately, she got lost and drove 9.2 kilometers on a bearing of 32 degrees. How far must she travel and at what bearing to reach Sean's house after getting lost? Okay, so first thing we must do is to draw a nice little diagram to represent the problem. So let's say Jamie's here, okay, and she's supposed to travel on a bearing of 192 degrees to get to Sean's house. So 192 degrees means you're not going south, but a little bit southwest. Not exactly southwest, but 18 degrees more. Or, sorry, 12 degrees more, because 192 is 180 plus 12 degrees. So let's say she's supposed to go in this direction to get to Sean's house, and that was 4.6 kilometers. And so this little angle here is 12 degrees. Okay, now, like I said, she's supposed to go in this direction, but she actually goes on a bearing of 32 degrees. So she goes on a bearing of 32 degrees and ends up right there. So this is 32 degrees. And she drove 9.2 kilometers in that direction. Well, that wasn't a very good idea. So now the question is, how far must she travel and at what bearing in order to reach Sean's house after getting lost? So we really want to know this interior angle here, okay? So let's say L for lost. Okay, we want to know that length there. I'm going to label as X. But in order to solve for X, I really want this interior angle, side, two sides and a contained angle, right? Side angle, side. So I don't have the contained angle right now. I can blow it up again, just like before. So let's say this is J. So this is 12. This is 32. So the angle here, that angle there, oops, sorry. This angle here must be supplementary to 32 degrees. Okay, so 180 minus 32 is 148 degrees. Okay, so now I can solve for angle J. So angle J is equal to 12 plus 148 degrees, which is 160 degrees. And now let's use cosine law. So we're looking at 4.6 squared plus 9.2 squared minus 2 times 4.6 times 9.2 times cosine of 160 degrees. And that is about, well, let's see. About 13.6. Okay, so we actually have half the answer. We know how the distance, how far must she travel, but what we don't know is the direction. Okay, so the direction's a little trickier. So what we're gonna do is go back to something we learned in grade 9. So hopefully you can see the Z pattern here. Okay, these are alternate angles. So this angle here is 32 degrees, but I don't want 32 degrees. I mean, that's a useful knowledge, but the interior angle that I've labeled there, you know, I'm gonna blow this one up too, might as well. Okay, so I'm gonna draw this one over here. So this is where she's lost. Okay. So this, the interior angle, I'm gonna label as theta. And the angle here, I'm going to say is beta. Okay, theta and beta. What do I know about theta and beta? Theta and beta must sum to 32 degrees because, like I said, alternate angles here. So theta and beta is equal to 32 degrees. You know, I'll try to show you theta's there, beta's there. Okay, so alternate angles, theta plus beta equals 32 degrees. Now what I'm going to do is solve for theta because it's the interior angle of this triangle. So let's use, you could use sine law or cosine law. I'm going to stick with sine law because I think it's going to be a little faster. So sine theta over 4.6 because that's opposite to theta. We have this angle of 160 degrees, so sine of 160 over x. So let's solve for sine theta. And make sure your calculator is holding on to x, so theta is as accurate as possible. You know, I don't really care about theta. I'm not even going to solve for theta. Okay, but I have sufficient information to solve for it, but I'm not that interested in theta because I am actually interested in beta. Okay, why do I want beta? Because if I know what beta is, I can tell you the bearing she must travel at in order to reach Sean's house from where she is when she's lost. Okay, so beta, so since theta plus beta is 32 degrees, beta is 32 degrees minus theta. So now I'm going to punch everything in my calculator. So 4.6 sine 160 divided by x, and an inverse sine, and then 32 minus that. So we're looking at about 25.4. I'm going to do that one more time. I'm going to start from the beginning, making sure I feel like I made a typo there. Okay, I got my 13.6, beautiful. So 4.6 sine 160 divided by x, inverse sine. Okay, yep, 32 minus, beautiful, 25.4 degrees about. So like I said, now that I know what beta is, I can solve for the bearing. Okay, I can solve for the bearing at what she must that she must travel at. So therefore, Jamie must travel approximately 13.6 kilometers on a bearing of, let's see, so beta is 25.4, it's 180 plus 25.4, right? Remember, you have to rotate clockwise from north, so 180 plus 25.4, we're looking at about 205.4 degrees. I think the part you have to remember is the alternate angles, and that might have thrown you off, but that's how you solve for the bearing that she must travel at. So that was true bearing, but we also have what's called conventional bearing. So conventional bearing is stated as a number of degrees east or west of the north-south line. We will refer to conventional bearing simply as a direction. This is simply an alternative method of indicating direction. So you could use conventional bearing, you can use true bearing, but if someone uses either or, you need to understand what direction they're stating. So 30 degrees east of north, I've shown you two different ways of writing it. 30 degrees east of north. So take it slow, really just read what they're saying to you. 30 degrees east of north. 30 degrees east of north. So don't go north, go 30 degrees east of north. So right about here. No, let's just draw an arrow, right? Yep. Okay, 30 degrees east of north. Let's do 6 degrees west of north. So if you read it slowly, it's really obvious what the direction is. Not north, 6 degrees west of north. So. Okay. That's actually even though none of my diagrams are drawn to scale, that's not steep enough. Or, yeah, it's not close enough to 6 degrees. Okay, that's better. What I drew was looked like 45, or more like 45 than 60. Okay. Okay, here, 70 degrees east of south. 70 degrees east of south. So don't go south, go 70 degrees east of south. And lastly here we have 80 degrees west of south. $80 degrees west of south, okay. All right, there we go. And now they gave us a diagram. We're just going to use, they want us to use both conventional bearing and true bearing in order to state the direction from the origin. Okay, so to get to point P, let's do conventional bearing first for all four. Okay, so that is 48 degrees east of north. 48 degrees east of north. So I'll write it like this. Okay. For this one here, you want to go 60 degrees west of south. 60 degrees west of south. For this here, this is 40 degrees east of south. Now here, careful, this angle is made relative to pointing west, but you want the angle relative to the north-south line, okay, not relative to the east-west line. So if this is 20, then obviously this angle here must be 70 because the two angles are complementary. So once again, you want it relative to the north-south line. So this is 70 degrees west of north. So now I've done the true bearing, I've done the conventional bearing for the four, but now I want to state the direction using true bearing. So this one's easy. Just rotate clockwise by 48 degrees. What about this one? This one is you have to go 90, 180, 180 plus another 60, which is 240. All right, what about this one? So 90, this angle here is 50. Once again, complementary angles. So 90 plus 50 is 140. Or you could have said, what is supplementary with 40 degrees? So once again, you'll get 140. Okay, last one here, 90, 180, 270, 270 plus 20, 290. Okay, so hopefully now you'll be able to state the direction using conventional bearing or true bearing, because in the word problems we give you, it might be using conventional bearing or true bearing. So you have to be able to work with both, because if you can't draw the diagram, you won't be able to do the problems. Okay, so let's jump to the problems in the next lesson.